Cool. Well, yeah, I just, hey, man, and automation engineer there. Yeah, I'm part of the QA group. I don't know if you know yeah. How are you? Yeah, right on. Oh, that's a first. We got we're just so really getting that page out and it's amazing. We're doing that stuff. Wow. We do it in inside sales because next level. That's where I'm getting to. But the old school guys at my work, they wow whoever makes decisions. So it's just this like it's a little bit of a disconnect, but that's how technology is. What's your last name? Chiang. Cool. I'll look for you on the Slack
All right, everybody. Bill's confident. Let's get rock and rolling. So, thank you everybody for coming. Normally I do a little bit of a spiel up here, but I know that Matt's got a lot of stuff he wants to get pounded through, so I'm not going to keep you guys this time. Thank you everybody for coming. We actually do a brown bag monthly here that you guys are all invited to. Quarterly, we put an emphasis on client brown bags and not a blended client and candidate brown bag. But, so I wanted to throw that out there. Our brown bag next month is on containers, Docker containers and containers in general, and just when they're good, when they're bad, they're good, bad, and ugly. We've been doing development with them for probably 18 months now. We've seen some successes with them and some, I don't call them failures, but some hurdles with them. So, Matt's going to talk to us today about automated serverless load testing in your CI/CD pipeline. And honestly, I'm just going to turn it over to you and let you go because I know you got a ton of stuff to get through. So
I do have a ton of stuff. So, little introduction. Matt Chiang. I've been doing QA for 21 years almost. Got started really young, just fell in love with it. I have a CS background, but I thought I like programming, but I wanted to build tools rather than building feature code. And that's where I started. I stuck in QA, started writing automation about 14 years ago, back when everything was on the client. Internet was still a 56K dial-up if you're lucky. That's when I got started. So we built automation tools to just get our job done. We had to install machines on a daily basis and do everything that that a user would do, updates to the system and all that stuff. It just took way too long. So I had to figure out tools to increase my velocity. The biggest success there was I had to set up 60 machines on a rack to do the testing. Took about 4 to 5 hours per setup. Got that down to a 10-minute block. I can consistently run updates, run installs, run whatever I needed to. 10 minutes. I need reset the environment. One button click, resets the whole entire environment, brings me back to a clean environment, loads up whatever I need, ready to go. So I can go to lunch, right before I go to lunch, hit reset, come back, I got my stuff done. And then ready to do the next test. So that's the background. I love automation. Anything that can make our lives easier, give us more metrics, give us more indications of where a failure could possibly happen. Those are the things that the true engineering aspect comes out, is I want to know everything before a client finds out. And hopefully this is helpful for you guys. A little background on the client that I have. The client right now is a commerce client. They've had successes, and with any type of commerce client, you always have your Black Friday sales, you always have your year-end sales, you always have your quarterly sales to meet your numbers. One of the biggest problems that everybody tends to have is you allocate a lot of resources that's sitting idle for all that time. You're paying for licensing, you're paying for maintenance, you're paying for engineers sitting around until you have those big sales. All of a sudden, you have the sales, and you realize, we didn't plan well enough. These are all the things that went wrong. Amazon, back for their Prime Day this year, what happened? A couple hours in, actually, was it even a couple hours? Amazon going down. What is up with that? They've built their whole entire livelihood on their systems. And we're actually using their systems. But luckily, our AWS stayed up. Amazon's main AWS went down. So we actually did pretty good with what we did. But it's not with its faults. There are still challenges we have. But hopefully the stuff that I've learned can help you guys see the future direction. And kind of like Brian talked about, next month we're talking about containers and Dockers. We're serverless. We're containerless. Technically, it's still inside of a container, inside AWS, but we're at a higher abstraction layer, so we don't really even get to worry about all that setup and all that. So what are some problems we try to solve with using serverless, and why we went to serverless? Well, how do you get real unit test? I'll get to this while we're trying to cover this unit test and measure code coverage. Why is this important? We'll get to that. How do you do integration tests with each code change? Everybody says, well, we got to get more automation. We got to do more unit tests, more integration tests, more UI tests. How do you get that? Why is this awesome? Okay. How do you do a load test with each code change? From my past experience, I've worked in a we had to set up a bunch of NOCs throughout the world, and our SLA was 99.999% uptime, which really meant in a year we could be down for 1 hour total. After that, we start losing revenue because the company that I worked with, we were doing data caching. And the more data that we can push through our system, the more money we make. The second that traffic stops, we start refunding money because it could potentially bring down the client system. So from my past experience, you do a load test every month. Right before you do a release, if you're doing monthly releases, you're going to do a load test. What did that really get you? You got a whole entire month worth of code changes, and you're trying to figure out, okay, who broke this? What change did we make? It's nearly impossible trying to track down a month worth of changes in a day or two. And then if you do find a problem with your multi-threading, I have in the past, multiprocessor. This is when multiprocessors was still pretty new. If you generate enough load, you'll lose a linked list. How many people face that? How do you lose a linked list in your memory? What happens? How do you recover from that? How do you fix a bug like that? You got to have enough load. It takes 2 hours to generate this one test, and then it fails, and then you get to troubleshoot. When back then we were troubleshooting with a COM port on directly connected to a server. It took about 2 months to fix that one bug. But after that, it was good. But let's get this done early. Let's find out all the changes. If we have a good established baseline, I want to see this trend if we're going slower or if we're going faster or if we're staying static. Hopefully we're staying static. How do you verify my SLA with the client side? So if you're on a web service system and you're testing your REST services, how do you make sure your SLA with the client is adhered to with every code change. Kind of tough. How do you get historical trend data? Kind of mentioned that. How do I not have to spend the GDP of a small country? How many people have spent, back in the day when I was using LoadRunner, is $1 million a year. A year. Some small countries have smaller GDPs than that. And we were spending that. And out of all the people that used it, maybe 5 people. And if those 5 people weren't using it, the license sat on the shelf. Kind of wasted, right? And how do I give QA access to everything? In the QA organization and in the dev organization, we all work together. We're a team. We're a unified team. You shouldn't have to say, well, I don't have licenses. I can only afford a license for 5 people. No, I want every dev. I want every QA. I want everybody. I want every project manager to be able to know what I'm doing and go through my code pipeline and push out code in production. If I'm on vacation, I don't want to have to worry about who's going to cover for me. I want to know, do I have enough tests built so that you guys can feel comfortable that you guys can just push buttons? If all these tests are going through with correct reporting and enough logging, it's going to go through production and it's going to be good. So we're going to cover that. And how do I streamline my CI/CD pipeline? This is the one that's going to be tough. I can't show you how to streamline it, but I can show you exactly what the model that we have and how streamlined it is. It's not with its faults, but here's a testing model. Manual testing is always needed. It's never not needed, but this is how you get faster and cheaper automation. We're not going to solve the problem of no manual, but what we're going to do is we're going to blow this up a little bit. So imagine your manual shrinking a little bit and everything else increasing a little bit. As far as what we're trying to solve with this. GUI testing is always slow. It's always expensive. It's always brittle. And it can't be guaranteed. And typically, from my experience with the UI side, by the time you get to UI, you probably have 5 or 6 different teams worth of hands inside the code, constantly, including the DBAs who's making changes, companies or PMs making feature changes. So sometimes you can't guarantee that your stuff is actually the same thing that was before. CI/CD pipeline, okay? What do we do to do this? So in our CI/CD pipeline, we're using Istanbul for code coverage, open source framework to measure out our Lambdas. The reason why we chose to go with AWS, it's containerless, serverless. We're writing small little functions, web services. And in each of these services, we have unit tests. Unit test, it measures each line of code that executes. It returns back your functions. It returns back every little piece. There's been times where developers add a new feature to the code, forget to write their unit test, forget to notify anybody about their unit test. I deploy the code out. Guess what? The build fails. It will not go into test until he meets the criteria of at least 95% code coverage. 95% code coverage, 90% pass rate. You can have one failure, it's okay. But if you think about a small serverless function, you're not doing too many things there. So if you have a get, put, post, delete, if you put 4 tests in there that covers all that, you fail one test, that's 25%. That's 75% success rate. You're going to fail the build. So all of a sudden, somebody makes a code change. They didn't think about what they're doing. They didn't adhere to the client side. We're going to break you. We're going to say you can't deploy. It's awesome. So here it measures the line in the code pipeline. So some of the automation tools that we use, everybody's heard of WebDriver. A lot of people use it. Very popular tool. It's free. It's awesome. Has its faults, but it's UI. What about load testing tools? Jmeter. Everybody loves Jmeter. It's awesome. What about commercial stuff? I don't have to name all these, but I'm pretty sure these cover pretty much you guys have experience with at least one of these. Okay. And some of these have like a rational. I remember using rational back almost 16 years ago. It's good. We use LoadRunner and WinRunner. It's better, but every time we have a problem with it, we get to wait 2 or 3 months before Mercury Interactive at that point fixes their stuff, gives a patch for what we need, and then we can move on with our stuff. Great tools. Some of these are cloud-based. Blazemeter is a cloud-based. Some of these have started moving to the cloud-based arena. And some Apache is free, or Jmeter is free to use. Okay. So what's lacking these tools? The one, cost. Every one of them have a different cost model for how many users you can generate. Sometimes you're capped off because of budget at 200 users. Sometimes you're capped off at 100 users because of machine resources. Sometimes there's memory on a machine. Okay, limited machine power. How many more machines do you guys need to set up and maintain in order to get your test run? If you're spending more time to maintain your machines than you are running your tests, that's not a good model to follow. Licensing. I hate licensing. I'm all about open source. Can you add any of these to your code pipeline, CI/CD pipeline, where every time you make a code change, every time you deploy a piece of code, your test kicks off? To measure that slight variation difference, no. Most of these are almost impossible. A couple of them, the cloud-based ones, it's a lot easier because you can just run a curl command against your account with a test name and it will launch your test. Biggest problem right now that I see with all these tools. I can't test wide, so I'm going to test deep. So I'm going to generate 500 users and I'm going to kick the snot out of all these web services all at the same time. Well, if you have 30 web services you're testing, how do you measure the one web service that's slowing down the whole entire performance load test? It's hard. And if that's the scenario you have to test, did it really buy you anything? Then you got to go troubleshoot, okay, does this web service? No. Is this web service? No. Who made the last code change that affected this web service? And when did this code change go in? It's hard to tell. Different reporting options. I hate reporting options. Generating a report should be simple. Latency, your response times, number of users, and errors. That's all I really want. If I see a high latency on my responses, I know we have a problem. If I see timeouts, we have either server ran out of memory, or it's having a hard time recovering, or it's doing disk trash. Pretty easy to figure out. CPU might be bogged down. What can we do to increase our velocity on our performance? So what is serverless artillery? Well, one thing's got a cool graphic. It's got a big cannon with a Lambda there. So a Lambda is just a small little function, the smallest of a function that you can think of in programming. And we're going to kick that off, and we're going to execute that as many times as we want to. Is it free? Yeah. Nordstrom's the one that built it. So what they actually did is they took two different frameworks, artillery and serverless, and combined the two. Artillery runs on EC2 in Amazon. Pretty good performance. But once you add serverless to it, your resources are not limited anymore. You specify how big of a resource you want, and it's going to start handing things off. You can scale horizontally. Now I can test wide. I don't have to test deep. If you look at any e-commerce platform, Amazon, Prime Day, how many people do you really expect users to come in at 5, 10, 15 editions per second? Or do you expect 20,000 to come in within about a 5-minute time period because they know that's when it's going to happen? That's what you got to test for. How about pay as you go? The more I use it, the more I pay. If I don't use it, I don't pay anything. The beautiful thing about Lambdas, they give you free resources every month. They give you 1 million requests every month for free. 1 million requests sounds like a lot, but with the test I'm running, I can eat that up within about 30 seconds because I'm testing wide. You do have to pay for resource CPU time, but We'll go through a brief little snippet about how the cost is measured. Okay. You can throw your code, it generates it. You can generate the load within about 3 minutes total. And what it does, it'll go to your repo, pull down your latest automation code, and fire that automation code off within about 3 minutes. So it's pretty instantaneous. And it is part of the code pipeline. The second the code gets deployed, this is just an action that's after. It's a post script. It's a post process script that gets kicked off that starts the build process for the artillery. So why artillery? Multiple protocols. It can test pretty much everything that you need to, with the exception of certain proprietary technologies that isn't readily available. Testing SAP, it probably can't do it. I don't think it ever will, unless SAP opens up all the protocols that they have with their communication. It supports very complex scenarios because you're in control of everything that you want to do. You're not using a GUI tool that is limited in function, and then you get to try to figure out the nuances of the tool. Whatever you can code up, whatever you can think of, you can build it. It gives you latency, request per second, concurrency, and throughput. Those are all the metrics I care about. I don't really care about everything else. I can watch the CPU on the server at that point, but if we're all in the cloud, do I really get to see the CPU? I don't get to see my CPU inside Amazon. They just tell me if I have invocation errors, if I have timeouts, if I have 502s, then I get to figure out why am I being throttled. Is it because of my account? Is it because we have a long-running function? Is our database query too complex? It's scriptable. It's JavaScript. How awesome is that? We'll get to what kind of JavaScript it is. It's extensible. So we'll get to what NPM is. The whole entire framework, we'll get to that. So kind of what we talked about artillery, it's about 300 requests per second just from artillery. How about 50,000 requests per second? How many times have you gone through a web service and you're like, yeah, we can handle about 2,000 transactions per minute? Is that enough? Maybe. How many load balancers do you have to add in there? How many servers do you have to put in there? How many times do you have to re-architect your Apache to your application server? You offload your static content, you move your application and your business rules to a middle-tier service, and you build up another back-end service to pull all the data, right? It gets complex. What if I need 50,000 requests per second? It's possible because I'm just using Amazon, and really all I'm going to do is just pay as I go. So single Lambda, you can produce about 250 requests per second at a 1536 power. And what happens when you adjust your memory, it doesn't just adjust your memory, adjust your CPU, gives you more cores, give you more I/O, give you more throughput. Nice thing is you don't have to worry about sockets. You don't have to be limited on sockets because your local machine can't handle more than 56,000 sockets, right? Yeah. So pricing looks pretty cheap. If I run 5,000 requests per second for a whole entire day, it's going to cost me 140 bucks. Times that throughout the year, not too bad. Still pretty cheap. This is how Lambda workers are going to run. You have your YAML script. You get to what YAML is. There's your time. Nice thing about Lambdas and the bad thing about Lambdas is they can only run for 5 minutes tops. If you're running a test that exceeds 5 minutes, it needs to have a handoff. So you have your control Lambdas that does a handoff. That triggers your worker threads. The worker threads are the ones that run all the testing. Once each worker thread is done, throw the info into either some type of reporting. You can use InfluxDB and Grafana. Artillery out of the box supports this framework. You just got to set it up in your AWS account. Artillery is Node.js. How many people work with Node.js? Server-side JavaScript. It's pretty awesome stuff. To get started, that's a line. I'm going to install the AWS SDK. I'm going to install Lodash. Install CVS parse to parse out my data. I'm going to do a moment to give me a timestamp, and AJV for JSON validation, and do a serverless artillery. That's the framework that we're going to be using. That's a single line of code that you need to run, and it will set everything up for you. Generating a script, boom, one line. What's your endpoint? That command line right there will generate 10 requests per second, scaling up to 25 requests per second over a 60-second time block. Some of these tests, you don't need to go long. If you're testing for an hour or 2 hours on your web service, at that point, you're not really testing your load and performance. You're testing more of how your server is going to handle with memory leaks. You're not looking at, well, can I still have a transaction and have it respond within 2 seconds or 1 second? So what does a script look like? That's pretty easy right there. That's a YAML script right there. That's your basic core function of your YAML. Give you scenarios, give you the flow. You have basic loops in here. You can add custom validation on your before and after requests and your endpoint. Here's your project structure once it's built. So the function JS, you can name it whatever you want to. That's where your JavaScript validation is. That's my custom validation to validate against the data types that's coming back against my web service. And if I need more validation on it, I can add whatever validation I want to with the data for the web service that's being returned. The serverless file, that is your serverless template file. That tells you where your account is, what resources you need, if you need Logstash, if you have CloudWatch, if you have X-Ray, all these different monitoring tools goes right to that serverless, where you want to store that data. The handler and the index HTML, that's actually the artillery piece of their built-in reporting. So this one here, we actually have a lot of extra reporting right now because we're still in a discovery phase. We've been doing this for about 5 months, trying to figure out exactly where the reporting works best, how to give everybody access to reporting, and does everybody know how to get access to the reporting. So we're still trying to figure some of these things out so we have additional extra reporting. And actually one of these, about a month ago, I had to run a test with 20,000 users wide, running for 60 seconds. That generated so much traffic that it actually limited our whole entire AWS account. Brought everything down. It's like you are invoking too many Lambdas. Your reporting is taking up 2 Lambda threads, 2 additional Lambda threads on top of your test, on top of your API gateway, on top of everything else. So we're actually kicking off some pretty awesome tests that generates more of a real world scenario of what happens on Black Friday. Am I going to get trampled over because everybody is shopping online? More and more people are doing that. Okay, so let's go back to the code pipeline. So back to the approval process. So here is a code pipeline. The second that the developers check in the master, they're ready for their code to be merged into the test environment, I get a notification. Here it'll say, do you want to deploy to test? Are you ready to deploy to test? Add my notes in, and you have to add your notes in. It'll get deployed to test. The second it gets deployed to test, the artillery scripts, which includes when it deploys, you're going to kick off your unit test. And if that unit test doesn't pass, remember, it will fail this. It will roll everything back to your previous state. So you will never have a bad environment. I don't know how many people have gone through a situation where a developer adds new code, didn't add unit test, really didn't check his code because he couldn't check his code on his in a dev or his local environment because it depends on a SAP database or Oracle database that you might not have a connection to. So you tell the QA, go ahead and push it out there. Let's see what happens. Push it out there, breaks. What's our fallback? We roll back to our previous production release at that point. Or if you're lucky enough, you have a timestamp for every snapshot that you have, you can roll back to the previous snapshot. Some companies aren't lucky enough to have that maturity level in the process. This one here, it's going to catch it before I even push it out there. It's going to push and it's going to break. It's like, sorry, you didn't put enough tests in there. The code might be working, but the developer didn't think completely through. It passes a lot of responsibility to the developers. I deploy to test. It invokes my artillery scripts. Now what happens if, let's say we have a cold Lambda. Our cold Lambda, so with Amazon, the warmer you keep your functions, the more money it costs you to maintain it. So what we do is when we're not using it, we bring it down to a very, very cold state. We might only have 5 worker threads open. My test kicks off, it starts ramping it up. And all of a sudden it hits a block, the server will automatically scale. It starts scaling up and up and up. Databases will start scaling. Every once in a while, that scaling, my scale goes a lot faster than what the server scale will go to. So I'm gonna have to kick off the test a second time. So I can do that. Once I get to the stage approval, or test approval process, it holds up for me. So I can do my integration test with my services, validate all my SLAs are correct. If I want to, I can kick off my client automation, verify on the client side everything's good. If that's good, then I can deploy to stage. And stage will be the same process. Go through that, go through deploy to prod. Now, once we hit production, what happens? What happens if we break in production? We've got to roll back. We can roll back immediately. Right now, we're also implementing canary deploys. So we can direct traffic based on certain parameters. And with the artillery script, what happens, you can also do scenario based. You don't have to do a post with every request. You don't have to do a delete with every request. You can say, I want 99% of my traffic to be gets. I want 0.1% to be post, and 0.1% to be deletes, and 0.8% to be puts. So you can shape the way that your traffic is going to be based on what you expect your average user behavior is. Watch this video, it's going to be quick. That's in the AWS account. All I did right there was kick off my whole entire artillery script. It took about 10 seconds to kick off. And after that, I kick back, grab a drink, come back, and then we'll get to the reporting here in a second. So yeah, this is more of a complex scenario that you actually, this is actually a working scenario. This one here, I kind of munched up all the client secret stuff. But you can pass in variables here. With most load tests, a lot of times I've seen you go and record your test, captures one user, then you got to go back and change your parameters and inject all your variations. You don't test with one user. Nobody logs in with user 1 for every test. I can stick 30,000 user accounts in here. I can stick 30,000 SKUs in here. If I have 100,000 SKUs, it doesn't matter how many SKUs I have. I can randomize it inside my script. I can do validation. If there's a piece of validation I need, so this one here, it actually tests our login feature and our remit feature. Our remit is retokenizing to make sure that you're still valid, you still have a valid credential. We're going to grab that that token as it comes back in the EID. We're going to throw the remit. In the remit, I'm going to keep on using that. So if you look at the loop, it's going to pause for 1 second between each request, and it's going to go through the test 60 times. If you look at most e-commerce sites, most people, by the time they hit 60 pages, they're done with the shopping process. So that's kind of what I'm trying to simulate here. So 60 seconds is all I need to test this feature. I don't need to go run for 2 hours. Node.js. This is Node.js part of the validation. I'm validating the JSON schema. If it's a string, it better return me a string value. If it's an integer, I better be getting a string. Well, if it's a numeric string value, I have custom validation that's written. It's actually a lot bigger than that. I kind of shrunk up my if statement there. If I want to validate every piece of data in the response, I can validate every piece of the data inside the response that the client would need. If I don't want to, I can randomize which ones I validate against. And then if there is something that isn't working, I'm going to spit it out to my log. And notify the report inside the report. I got a validation there. You better check on this. Then we're going to go look at Logstash and look at Elastic and try to find a request that failed and which ID it failed on, which SKU it failed on. When you're testing against 30,000 SKUs, trying to find which SKU has a bad piece of data, that's pretty hard. But you can customize it. You can customize your reporting. Reporting options. InfluxDB we mentioned, CloudWatch, Logstash, Grafana, artillery report. We're going to cover the artillery report. The other three we have, there's more company secrets in there that I can't show you guys, but artillery report, I can show you guys. It's pretty basic reporting, but it gives you everything with it. and you need to know about how well your service performed within about a 5-second block. Pretty easy. Okay. And before we do that, let me show you the reporting. Artillery reports. Can you guys see that, or do I need to blow it up a little bit more? There we go. So in this test here, it all went well. I ran for 210 seconds. I ran 1,500 users, 1,501 to be precise. The reason I do the 1 is to do initial test. If that initial test fails, I don't need to run the rest. I don't need to waste money. Yeah. So if that 1 fails, I'm not going to kick off my next phase. I'm going to kick off 1,500 users at the same time for roughly about 180 seconds. It takes roughly about 210 seconds to complete. You can see my distribution with latency. You can see my latency intervals, which each request is coming back. Right at first, it's called Lambda. You can see the response times being taken a little bit longer. All of a sudden, it starts dropping. Latencies gets up a little bit higher. Lambdas are all coming back. You can see my user distribution. In this test, I actually do have a little ramp up and a ramp down. There's other tests where it's just a straight bar across. You get a little bit of inflection, and it's just a straight bar across until you finish the test. So you can shape your traffic. Responses per second. You can measure what your responses is. Once I hit about here, I'm getting about 600 milliseconds per request. Request. So when I have the peak, I'm hitting about almost 700 requests per second. This is small scale testing. This isn't large load testing. Request count. Our servers are handling about 6,500 requests per second. And HTTP codes, how important is that? Don't you just love to see H200s all the time, but you're never going to be guaranteed. What happens to get a 401? What happens to get a 502 or 501? What happened to my code? And we get the raw data here. This one here, we don't have any validation errors. This one here didn't go so well. This is not a healthy system right here. This is our product Lambda. Our product Lambda spawns off 3 other Lambdas, goes against 2 databases, 3 database tables. And as you see here, at first it's pretty good. All of a sudden, we had our cold start. That's all the resources we have. Now it's going to start spinning resources up in AWS. You can see my users are going to start climbing. And all of a sudden, because I had so many failures, my test actually scales down to see how well it can actually handle the rest of this. And right here, if you see this, the latency, it actually just stays up there. And we actually found a pretty major bug. When you have 1 SKU in your request, it's really quick. The more SKUs you add, the longer the request takes. And if you have a SKU that isn't inside of our cloud database, it has to come home to find it. That response time, that latency, increases almost exponentially for how long it takes. And all of a sudden, with that many users, our requests are averaging 8 seconds apiece. And we're getting constant 502s, and we got timeouts. We've got a couple 401s because our tokenization was hit too. And it stopped giving out tokens for your authenticated user. Here's your HTTP codes. All of a sudden, it's good, it's good, it's good, it's good. Boom. It's almost synchronous with how easily you can see your requests. Here's your error code. It just goes up there. And then this one here, I do have validation errors. This is the part that I haven't figured out yet. There's custom reporting on this. I can log a cumulative number of the errors that are coming through. For some reason, it's not working in this in the handler code, so I got to go fix it. The nice thing is it's all open source. You can publish. You can check out the code, make a code fix, publish it to NPM, and you got a project. Just do NPM install on every project that you have, every function you have, and you have it done. Had to do that where this is actually using a custom artillery because in the artillery we have to have our our authorization piece has to have a camel case for tokenization. When their code, it doesn't support camel case in the headers. And so I had to make a code change on the artillery side to allow for the camel cases. But it took about 3 hours, published it out there using our own project now. And that there's a pull request to the artillery core. We'll see if they take it. If they don't, no big deal. This test, like I said, you can run your test for as long as you want. This one's only running for 60 seconds. This one here is running for 130 seconds. This one got a timeout here. We hit our invocation limits. Okay. Now let's go back to analysis. This is the part. This is the part that everybody loves. Free to use. Awesome. Love free stuff. You need dedicated machines. Each machine, I can go above average about 100 to 150 users before I get weird inconsistency. So I just keep it around 100 users per machine. When we first started this project, moving everything to the cloud, I was using Jmeter because it's free. Most people know about it. Everybody there's plenty of resources out there to help you get started with it. After 100 users per machine, you get this Java laying out a memory heap space at random. It's not very consistent. I can't guarantee my test is the one that's bad, or if it's a server side that's bad. Can't guarantee it. So if I want 2,000 users, I gotta get about 20 machines. Now I gotta maintain those. Once I run each test, I gotta calculate all the metrics myself. Yay, gotta love that. Copy paste into an Excel spreadsheet, calculate your sums, divide those numbers. What if you have a calculation error there? Artillery report, there's no errors there. Everybody uses that, so, and it's open source. Everybody knows how to do calculation there. So you got other people watching your back. So then we thought, let's go to Blazemeter. It's cloud-based. $649 per month, pro version. 5,000 concurrent users. That's pretty awesome. 80,000 virtual user hours. That's not awesome. 20 load generators, okay? Or you can get a discount rate of $6,000 per year if you pay for an annual license. Let's go back to that virtual user hours. Every company has a different model for how they charge you. 80,000 virtual user hours is not a lot of hours. If I run 2,000 users, I run the test for 1 minute, that counts as one full hour. They round up to the hour. They don't round up for the minute. With AWS Lambda, they round up to a full 200 millisecond. 2,000 users will use up 2,000 hours. You can look at this right here, and that's per year. That is not per month. So within about 2 weeks, I'm going to exceed what I'm going to be using for the entire year. All right, what do? Give me the own enterprise. They came back with a $50,000 price tag. For 2,000 users, we get more hours, 8 million user hours, and only 4 load generators. If we want to do that, they said we can come back and give you more load generators if you guys use it up. Great. How much is that going to cost? We don't know. Magic sandbox there. Okay. So let's say 2,000 user hours. How much does that break down to 8 million user hours? If I use 2,000 hours per test, 2,000 users, I can roughly run about 4,000 tests. We have 12 Lambda functions out there, about 333 times per test if I break it up. That's pretty good numbers there. I can run a lot of testing. Okay. What about LoadRunner? You can't find what the cost is. I just know from back in the day, from years and years ago, it's $1 million for our enterprise license. Today, you can find a pricing model. $140 per user day. What does that mean? You can use that one user for a day. It costs you $1.40 per day. So using their calculator, I punched in 2,000 users per day for 5 days. 10,000 VUDs. $25,000. 99, that's the highest number I can punch in their calculator. It's almost $140,000. Cost of Lambda. You can get the pricing details here. Remember, they do have a free tier that you can use. I did not include any of the free numbers in here. If I run the test for 180 seconds, 2,000 user hours, 1 second per loop, 4 requests. I do a get for the authenticate, and I do a get, put, post, and delete. Put or post, delete. Now, if I do that 330 times per test, right? That previous line was supposed to be there. 333 times per year to run that one test. The 12 tests will cost me $864 per year just for the requests I'm generating. Cost me $12,000 machine power. Total bill is $13,000 is our estimate. And right now, because we don't have to constantly run these tests every single day. Some of these tests we ran for the first time. We ran a couple times, figured out all our latency issues. We added more caching. We're using DAX from the front end, certain things. We're doing Dynamo cache. And we're expiring cache a little bit longer. And we can play with all these different caching mechanisms and run these tests. Once we're done performance tuning that feature, as long as we're not adding more code to it, because it's a Lambda, it's all isolated by itself, we don't have to rerun the test over again. We only need to run a test when we have a code change. So actually our bill right now, I think for the last 5 months, less than $2,000. And we have 12 tests written. So what else can you do? Can you do UI? Absolutely. Serverless Chrome, headless. Everybody loves UI testing, but it's too slow if you have to generate, if you have to watch the DOM to paint. We can do serverless. If you want a full DOM, you can do a full DOM. You don't have to. But using headless testing, you got plenty of options. There's one case study. I won't go into too much details, but here's a case study you can read about. This guy is part of a education group. The biggest thing right here is that 1 year ago, we test our UI test, take hours complete. Last month took 16 minutes. Today it takes 39 seconds because they are spawning all those threads in AWS. They don't need to maintain their own grid. They don't need to maintain their own systems. They don't need to maintain their own Selenium nodes. Let Amazon handle all that. Do what you want to do most and not maintain your infrastructure. Maintain your test. 39 seconds. There's been times where we do a release and we have emergency patch we got to go through. I can't wait for days to validate that. I can't wait for hours. I can wait for 39 seconds because most of the time it takes us that long to just go grab a drink, if not longer. So that's a presentation. It's kind of a sales pitch, but it's easy to set up. It gives you a lot of features. It gives you a lot of flexibility, and you can control your cost. And it's easy to sell. You're like, yeah, I don't want 2,000 users for the entire year. It doesn't cost you that much, a couple $100. Questions?
The second report that you showed that didn't go so well. Were you shaping the traffic there, or was that, so yeah, scroll down just a bit. A little bit more. So that second graph there.
Yeah.
Mean RPS. Did you shape that, or was that just a natural thing?
Matt, also, thank you for taking this question, because this is being recorded, so we need to hear what he said.
Okay.
So we repeat the question.
Okay, so the question was, in the second graph here, did I shape the test? And the answer is yes and no. So most of my tests, I do a ramp up to warm up the Lambdas. If I hit it all at 20,000 requests all at the same time, or 2,000 requests, it's guaranteed failure. So I do a slight ramp up and hoping that our auto scaling can handle it quick enough. And right now, I think we have our auto scaling at, once we hit about 50% of our invocation threshold, it's going to start scaling up faster. And it's going to go double and double. So if we need to increase that scale 4 times, we can. But with AWS, you actually are limited to how many times a day you can increase your limit. And that's capped off, I think, at 4 or 6. So if you say, well, I'm going to have a user load of 30,000, and it takes 6 increases to get to that, hopefully you can get to that. Most of the time, you might not even, your account might not even allow it. And also, what if most sales events, people start coming on, more people coming on, more and more people coming on. So this is what's kind of simulating. And once we reach a certain threshold, our database queries were taking way too long, and that's why our request per second completely dropped.
So the decrease was triggered by database fails.
Yeah, the decrease is generated from the database failing. Our services was starting to fail. Our Lambdas was running for too long, and it actually cost more money. Easy test. My test was probably about 100 lines total code. And because it's so isolated, we can push out to production and we can roll it back. And so the other part of this, the reporting that's awesome, is we have the reports being sent to Microsoft Teams, and we have sent it to Slack. Well, there's a Slack channel for it. And on the Slack channel, you can see here's a load test completed. You click on this, boom, it pops up this report. Everybody in the whole entire organization has access to this. I don't have to feel like I'm hiding some numbers or I'm massaging a number. I can't massage this. This is where our code is. What if you said, well, what happened to before I pushed the new code out? Guess what? You got a historical trend of all your tests that's being run. Go click on it. So yeah, before I pushed out your code, nice smooth sailing. I pushed out your code. Look at this, 8 seconds. Developer actually just barely fixed it right before lunchtime, so I haven't had a chance to push out his code yet. But the beautiful thing about doing this kind of code pipeline, and if I'm not there, last week I went on vacation. I had another guy. It took me 2 hours to say, here's your code pipeline, push this button. If it works, if you get this report, no validation errors, go ahead and promote it. He promoted 2 services into production because we found a bug, but we had enough tests in there that it was a very extremely edge case for a particular payment token that wasn't being generated. So once we got that, we pushed that out. You didn't have to add any more code. We added a piece of data validation to it in our data. So if you look at one of the slides here, and I'll show you here, we have these data sheets in here. We just have to check in, grab the data sheet. Where's it at? Data file. Just add the data into the data file, and all of a sudden, he's got his test done. We're going to randomize that test. He gets this report. We push it to production. We pushed it from development into production in less than 30 minutes. It makes it so much easier. It's cool. It's cool stuff. If you want to do a DDoS attack on somebody you don't like, go for it. It comes with a lot of power. And usually with Amazon, once you reach a certain limit on your Lambdas, on my test Lambdas, they will start capping off my account. So they'll say, you generate too many tests, we're going to have to back you off. If I need to, I can call up AWS or hit up their support, say, can you give me more resources? So yeah, we'll double your resources. And since we started this project, moving everything to cloud, we've already had to increase our account limits, I think 3 times now. Each time doubling. Costs a little more money, but it's better than paying $250,000 for a CPU license inside Oracle. So, any other questions? So I have.
Framework again? I don't think I quite caught that piece.
So this one here, there's